This is the timer, um, the acceleration timer using a paper timer. I'm going to show you how to do the calculations for this. And this is one method for determining acceleration and the height of a distance something falls. To start off with, there's a series of calculations we're going to do. I'm going to put the equations up. First, we've got to determine our final velocity. So VF equals the total distance traveled by the amount of time. And we're talking about time here. We're talking about the time between two dots. And it gives you right here, 0.167 seconds. Now, it says 4 centimeters. I cannot use 4 centimeters. I must use meters for this, for all this operation. To convert this is very simple, right? You just divide it by 100. And you end up with 0.0400 meters. You got to keep these zeros. Those are significant figures. You have to have 3 significant figures in all your answers. And you have to round properly. So if I was to find my final velocity, it's very easy. Final velocity equals 0.400 divided by my time, in this case 0.0167. I'll get a final velocity. Now, this is one of those things we have to round properly, okay? Of some really long number, 2.39, and it kind of goes on. 5.2 something. Well, we have to round this to end up being 2.40 meters per second. I want to circle that answer, box it, okay? The next stage is that you count all the dots. Now, they kind of cut off on this page, but I'm going to let you know I have 19 dots. So my time, total time something's in flight, is my 19 dots divided by 60. There's 60 dots being made a second. That's going to give me a weird number of 0.316 that repeats. Now, to do 3 sig figs properly, this would round up, so it's actually going to be 0.317 seconds. And I circle that answer, okay? The next stage is going into the acceleration part of this thing. I'm going to change my color, make it a little darker, all right? And so, looking at this, it is my final velocity, VF, minus my original velocity, which I can call VI or VO, whatever you like, divided by my total time, okay? This time needs to go in here. This has to go here. My initial velocity, it's in free fall, so it starts from 0. So I can just leave this out. So I'm going to end up with 2.40 divided by my time of 0.317, okay? And it's going to give me a number. And if you round properly, you should get exactly what I get, 7.57 meters per second squared. That's going to be my acceleration, and I will circle it. So, if you notice, it's a cascade of equations, because now this one's going to be used in this equation. This time gets used again. This is total time. It's going to be used here. So to write this out, it's going to be 1/2, right? I can go 1/2 times my acceleration, 7.57, times, right? In this case, it'd be 0.317 squared. If you do your calculation correctly, you will get a distance of 0.380 meters. Now, ultimately, we want to see how close we are to what is considered the known values. We know, and I'm going to change my color, right? Let's go in here. Let's go back to red here. Can't really see if that's red. Well, there we go. Good enough. The known acceleration is 9.81 meters per second squared. So I'm going to compare these two numbers, and let's say my known height, and that's the lab bench, okay, is 0.375 meters. And I'm going to compare these two to my experimental. So these are known, these are my experimental. So I'm going to do this one over here first. Let me lighten this thing up a little bit. Okay, so I take, and this is absolute value. So we don't really care if it's negative or positive. We just see how far we are from what's known. So it's 9.81, that's our known distance, minus our experimental, 7.57, absolute value, divided by 9.81, you would get a big number, actually. Scientifically, we don't like them when they're this big, but it's 22.8% error. If you completely did significant figures correctly and rounded properly, that's the number you get. If we take these two guys, this is a bit of a different story. It's a 0.375. That's our known distance, minus our experimental, 0.380. And if we're going to divide it by our known value, 0.375, you get a great, fantastic percent error of less than 5. It ends up being 1.33% error. Okay? Now keep in mind, you're going to get a weird decimal, but then you have to multiply it. When you do this calculation, you'll get a number and you have to multiply by 100 to make it percent error. Okay? So this is straightforward. This is one of the techniques we're going to use using the ticker timer.